All right, boys and girls, new topic today. We are going to work in the access list DHCP Snooping Lab. This is about 3 tasks in total. We are going to read all of the tasks that we need to complete and then go over the commands and trying to understand with the topology what exactly do we need to do and why. So let's start working on this event. Let me go ahead and pause the video or maybe actually stop sharing the video so we can focus in the content of this event. So first thing, you download the package tracer file and we are going to read the instructions and then go over each of the tasks that we need to complete for this specific event. Let's go with the instructions. Lab number 10, task. Refer to the topology. All physical cabling is in place. Configure local user accounts, modify the name ACL and ACL, and configure DHCP snooping. The current contents of the NACL must remain intact. Configure a local account on GW1 with telnet access, only on virtual ports 0 through 4. Use the following information: username, password, algorithm type, privilege X level. Okay, so this is basically the information that we need to use for the lab. Later on, we have the task 2. Configure and apply a NACL on GW1 to control network traffic from VLAN 10. This is Corp ACL. Then we need to allow boot P and HTTPS, those traffics, those kind of ports and traffics. Restrict all other traffic and lock the ingress interface, source MAC address, the packets, source and destination IP addresses and ports. All right, we're getting there. Let me just share the video again. So let's analyze this topology. So we have the internet, we have VLANs 20, 10, we have the gateway. It's actually, the router is the gateway to get to the internet, GW1. We have VLAN 10, VLAN 20, VLAN 20, VLAN 10. We have 3 switches. That's basically the topology. And the router will act as a DHCP server. Let's read the last task that we have. Configure SW1, enable the DHCP snooping for VLAN 10, disable DHCP option -82 data insertion, enable DHCP snooping MAC address verification, enable trusted interfaces. All right, and I don't really see like an addressing scheme here, so let me take a look at the other one to see if they don't really give us like an address in the scheme. That's interesting. So how do we know we need to permit these IP addresses? Is there like some IP addresses there in the topology that we can actually see and validate? This is the addresses that we need to allow for the second part of the job for the gigabit W1. Oh, we will look into that in a moment. All right, let me take a look at that. No, I don't really see the reason because we need to configure those exactly, those specific IP addresses. Maybe if we look into the configuration of router one, the GW1, we will be able to figure that out. So we will do that. We will do that in a moment. Let's do the following. Let's go ahead and go to GW1 and start analyzing that topology. I want to do something real quick. I want to run the show CDP neighbors and show IP interface brief command so we can see what we are dealing with. Because it's strange. They're supposed to give us those IP addresses for the network that we need to configure, but let me take a look at this. So let's do the show IP interface brief first. Okay, yeah, we have the IP address of 10.1.1.1. Let me see if we are using it anywhere. Actually, the network that we are working on is the 10.10, the 10.0. We will look at the other devices in a moment. What about show CDP neighbors? It is not enabled. Let me look at the switch information for a moment. Show run. Okay, so basically that is covering all the 10.10. Oh, there is an IP address of 10.10.10.2 in the switch, meaning that some of these devices in VLAN 2 and VLAN 20 have those IP addresses that we are dealing with for the ACL. Let's do a show run here to see if we have anything there. So basically the information is in switch 3. The network that we are dealing with is the 10.10.10.0 with that /24 MAC addresses. They should provide us that information, but for some reason it's not there in the instructions. Let's double check real quick. It doesn't really show. All right, let's go ahead and start with the first part, which is the security part. We need to add some information on security. That is in GW1. So let's go to GW1 and start doing some configurations. Let's start with the enable command. Config T, configure terminal. And now we are going to type username. What is the name of the username that they told us to assign? In this case, it is actually Will. So we have to do the Will here. Please be careful because the exam can have a different username and passwords. Privilege 15 there. We have a secret. What is the secret there? Log 3 path. Now, line BTY04, transport input SSH is actually telnet. Be careful about that. Is telnet. We have to make sure we are configuring telnet here in router 1. Be careful because if you write SSH, you will lose the lab and you will be in trouble, losing a lot of points, which are important to pass the exam. Login local. Login local. So they give us the username, they give us the password for the secret. The encryption is a script, the algorithm. We are doing transport input telnet and then login local. That's about everything that we are doing. The exit mode, the privilege level is right there. If we are doing a privilege 15, so we are doing username, will, privilege, 15, secret, and then the password for this secret. Then we are doing all together with all of this configuration, we're doing the algorithm type at the privilege level. The privilege level is right here, and the algorithm is running in all of these commands. After we apply the transport input telnet and the login local, we access line BTY04, transport input telnet, and then login local. Let's do an end at this moment and a write so we can save these changes. Now, what are we going to do is in the same device, in the GW1, we have to configure an ACL. So let's follow along with the instructions and what we need to configure here. Let me just order this in a structured way. Let me start sharing the video for a moment. I want to have a more visibility and show you guys all of this. Okay. Now, let's work on the second task. First thing we do, let me just go there a little bit. Since we cannot really see the instructions there, let me just go there to see the instructions. So we need to configure an ACL. If it is already configured, looks like it's not configured. We need to create it from 0. Allow some ports, restrict some accesses and some traffic and destination and source addresses. So let's work on that. The first thing we do is go to the GW1 and we have to type the following command. This is an extended access list. How do we know that? Because we need to apply the control network from the VLAN 10. Okay, and we are dealing with source and destination. When we are dealing with source and destination networks, we are working along with extended access lists. So that is the clue, that is the tip that they are giving us to know that we need an extended ACL. Let's start with this one. The first command is configure terminal. Configure terminal after running the enable. And we are doing IP access list extended corp and then underscore ACL. Let's make sure this is the correct name for the ACL, and there it is. We are clicking enter there, and we can move a little bit down because right now we're going to permit some traffic, especially UDP traffic for boot and HTTPS. HTTP is actually TCP traffic. So let's start with the boot PC traffic with the following commands. First, we do a permit in lowercase, everything in lowercase. UDP, any equal boot PC. Be careful when you're typing this. That is the first one. And the other one is the PS. Let me double check that I'm running everything good. Yes, it's UDP traffic, any equal boot PC and boot PS. Now we are working in the HTTP option, permit, TCP for HTTPS. We have the network 10.10.10.0, 000.255 is the wildcard mask of /24, then any equal 443. That will be the port for HTTPS. Now we have to apply the access list. So we are going to do an exit here, interface gigabit 00, and we need to apply the following command, IP access dash group corp, the name of the access list, extended access list, corp ACL in. Why in? Because we are configuring this in the gigabit 00, which is actually in this topology is the Ethernet 00 that goes to the internal network, and we are applying the ACL for that specific internal network. So that's the reason because we are doing this way. And now we have to save the configuration, of course. After adding all of these commands, we do an end and then a write. Nice. So remember, some of the options we need to configure here. The name of the extended ACL, the UDP any equal boot PC and boot PS, the TCP to access to 10.10.10.0 and wildcard mask of /24. Are we missing something? Yes, we forgot the deny. So let me go ahead and copy this again. I'm just going to copy all of these commands because when I was running this, I totally forgot about that. So let me just paste all of these commands again, do an end and a write. So be careful. You cannot do this in the exam day, of course, but we are doing it for testing purposes. Mainly, I forgot the deny IP 10.10.10.0.000.255 any. It is important to add that configuration as well in order to deny the rest of the traffic that is not required. So we are only allowing the UDP traffic for the boot PC, boot PS, and the HTTPS traffic. And we are denying the rest of the traffic. After that, we access the interface gigabit 00. We apply the command IP access dash group, then corp underscore ACL, and then in to apply this for the internal networks. I think we're good. We're good now. We should be all right. So the next step is DHCP services. We have to do that in switch 1. Be careful that you access the correct switch because we don't want to create a mess here. So switch 1, remember that that is the correct switch that we need to work on. So let's do the following. Let's do an enable and then a configure terminal. Now, what commands do we need to apply the DHCP snooping and the 102.1 and the 82 option and the MAC address validation and trusted interfaces. Let's go to the commands that we need to apply there. The first will be IP DHCP snooping. That is IP DHCP snooping. Okay, now we need to apply to the VLAN interface. It's actually VLAN 10. So did they stated that? Of course, they told us to do it in VLAN 10. So let's do it. Let's go with the following command, IPDHCP snooping VLAN 10. We're basically repeating the same command and adding VLAN 10. Then we have to do the no IP DHCP snooping, and then verif is information option. When we are applying this command, no IP DHCP snooping information option, we are disabling this option 82 data insertion, mainly for security purposes. Now, what is next? The next step is to configure the MAC address verify. So we do the following command, IP DHCP snooping, then verify. Then we have to do MAC address. We have to do now the interface, a range, FA 0, 1 through 2. So we are covering the interfaces. The interfaces 1 and 2 in this range. Where are those? This is the interface 1 and this is the interface 2. That meaning that the interface that goes to switch 3 and the interface that goes to switch 2 will be we will be adding this protection there with the command IP DHCP snooping trust. Let's run this command. IP DHCP snooping and then trust. Let's validate the functionality of this command. Why do we need it? Because we need to trust those interfaces. So the reason to run this command is to trust these two interfaces that go to those switches, these specific switches. Now we type exit, and then we have to do a write. Once we have completed that, we have to validate that we save the configuration both in the router, the gateway 1, and the switch 1. Looks like we have successfully done it. So we should be all good. It doesn't say that we have to do any validation, so we are fine. But we can do something interesting, like maybe send some traffic. Let's see if the PCs have any configuration. Let's see. Yeah, they have some configuration. So maybe we can do a ping test to some location for the PCs. Let me work on that real quick. Let's go to one of the PCs. Let's go to host C and see if we are able to access some of the traffic. Okay, let's do the following. Let's run the following command. Let's run, for example, so we're trying to get to the internet. So let me run this command. Let's do a ping test to the 200165.201. But instead of a ping test, we are actually going to do an HTTPS test for this IP address, just to do a test in there. I'm wondering if there is like a website configure or something. We're supposed to get there, but with the HTTPS server reset connection. Interesting. So one of the PCs should be able to access a specific web server, but looks like there is not a web server configure in this topology. So maybe we will not be able to do that test after all. Let me see if we can just do a ping test real quick. So ping test is not reachable because the only option is HTTPS. But since there is not like how can I say this, like a web server configure after the internet, there's not much we can really do there. Show run. Okay, 92.com. I'm wondering if there is a website or something created in this. What about 92.com? What if we try to access that? Let's try it just as a test. I cannot guarantee that it will work, but I'm just going to give it a try. 92.com. It doesn't really work because those services are not created. We may have to add a server and then add these services and add the IP addresses and do all that. So we can do some testing and try to access the HTTPS server from the computers. But we're not going to do that for now. That is everything we have to do today. I hope that you have learned something new. Please keep practicing because remember, practice makes perfect. And the more that you practice and the more labs that you do, the better prepared you will be to encounter any certification exam or even a real world scenario like this in your company or where you work. Boys and girls, let me just activate the camera to give you a farewell. So take care. It's been a pleasure working along with you guys today. And I see you around. I see you in the next lab. Goodbye.